So let's get started. We will use some notes at the beginning. We will use for now. First, we like our line pipeline. Second one, be our working space. Third one will be like for visualization. Our last one will be like for debug purpose. In our PDG visualization, we will prepare two nodes. First, no geometry file p PDG output 0 and use you need this one, and the second one will be one. But if you don't know what the sorry, mistake, I copied wrong. If you don't know what the or why I am using .0 .1, if you write like that, it automatically brings the first geometry in the PDG output attribute. But in our case, we will need two or more, basically 2 or 10, because later on our work item will have one central train and 9 pieces around it. So we will use later on during debugging basically 10 outputs, because our geometry with all the terrains will use one work item. So we will use discrete 10 inputs we can copy. So PDG is debug, and we can prepare more of them, like maybe just now I will create just a little bit more. We will use later on another case or another stability, like force its number loop, and we will use this one inside and construct our custom attribute here. It will be later on. Just now, visualization debug, we will keep it off. PDG is our main. We will keep like this one. Put, we can keep it off for now. Terrain pipeline here. We can prepare null point as the default. So if we later on save this and as an HDA, we can drag and drop to Unity or Unreal Engine. We can simply see that it's correctly stored at 000. Or, so that's null here, and here you our top network and say like pipeline network. Okay, here we will use draw heap. So we will set up the project, save it, and we already save it. Now tutorial, the simulation heap and project is set to this, so automatically it will create proper names. Default schedule we will use the default on, and let's see, everything is like default. Here local scheduler, we'll use that. Total slots, we will use custom slots like 5. We will keep slots low because in our HD processor we will use VAX or terrain nodes that are multi-threaded, so we will process less mm, less work items together to use more threads for simulation in one work item, so we'll keep it low. And custom slots, okay, workspace directory, working directory. Here we'll like temp, the tip temp, and here I will create folder temp. So our uh, whatever this scheduler will create, it will be saved in this temp directory, and later on after crash or something happens, you can simply delete it, but it's inside the temp directory, so it will not spam these temporary files to our geo or texture folders. Okay, default mapping global location temporary directory open directory open pg. Okay, yes, delete temp directory. uh, it's whatever, doesn't matter. Okay, so it's our process or our basic up network now. And here range 0 to n 0 to 7 like that, and that's it. And maybe last one, integer, and we will use grid size, grid size, size. Here. Okay, apply that. And you can see now here we have our option, but this value is not what we will use. We will use the tokens. So like token 0, token 1, token 2, token 3, token 4. So in this case, in our equation, it will be like 4. And what that equation is? Put Wrangler, Wrangler once. Okay, first, if you sine eta, no, sine eta, and here we will be our equation. It will be integer. We will use this attribute, this integer attribute. We will use in our work items. So let's write the attribute here, and here is our equation. And what equation is? Base is 64 times power and power to size eta. That means that size eta is our terrain prepared resolution, unity terrain resolution. So copy parameter is inside. And now we can see it's 4. If I change the resolution 64, it will be 0, like 0. So it's like 64 times 2 to 0 is 1, so it's 64. If I go back to 1.24, it will be like 64 times power 2 to 4. And if I calculation, what is it? Calculation 64 times 4, close brackets, 16, 64, 1k is here. So it's our equation. You don't need to manually write 1k, 2k, 4k. In here we will use our menu. Here, simple, like that. So it's our equation. Here we will use size. It will be use directly this one. We'll use size, someone size, and size. Now we will these values these values, we will compute how big our terrain needs to be. For example, if I put 1000 here, we cannot use, or maybe we can, but it's not using all our resources in proper way. If I put like 1000 here, we will compute that for terrain resolution, we need to one tile. If I put 2 kilometers to 2 kilometers, we'll use 2 tiles, so 4 tiles together. But our target size will be not 2000, but 2.1k. So it will be like, okay, so our final terrain size will be like a bit different than we specify here. But basically, we don't need to compute the exact number in memory. We will put, okay, I need to terrain which is 6 kilometer wide and 3 kilometers tall, like that. Grid size, it's like resolution, so we will use 1 meter resolution. Okay, train prepare. Uh, Station. So our count will be filling function x size divided or in line size. Now, to proper divide it, these two values, 6 6,000 and or size now it's 1k. We need to cast this integer to float, so we will have a number like 3.5, and then we will ceiling to 4. So we need to recast some values. Same for y. So y count is just same. We can copy this and use only y size. And another one equal size will be like x count times line size. Like that. Second y plus size y count line size. That's it. Now we can check spreadsheet side colon, okay, bracket, brackets here. It's correct or not? Brings a floating chair explica inside. Okay, which E, E, E. Now, if we check detail attribute, we can see now um, stage numbers. Why? It's because big numbers, big letters. Sorry. So now we can see that our computation work. So our target train size is 1K. If we put here half K, we can now see we will need 20 tiles on x-axis, 6 tiles on y-axis, and our terrain will be not 6 kilometers to 3 kilometers, but only 6 kilometers and some meters and 3 kilometers some meters. Okay, so it's our computation. Now we'll create height field and we will use some attributes here. So we can add input, use this computation to fill our size, size, copy parameters, paste out reference. Here, our size will be our value -1 is spare spare input. It will be our attribute. How it we write it? It's count and y count. In count 0 index. No, then size. You need the line size, not real, not real line size. It will be the same because iconity and maybe Unreal 2 need square. So 000, it's okay. So our first train now super important because if we check here our resolution or size is 512, but Unity and as well Unreal Engine need this one plus one. And how do we do it? Just like use corners. Why corners? Because if we check this one and uh, convert height field, if we convert it to polygons, because we will use the terrain as a polygon map. But Unity and Unreal, this map requires 2 points or vertices, and if we that's why we need one resolution or 1 point in x-axis more, because if we like use this center, like value height is 100, we need that value put on the left, but here at the end we use that value on the left. We don't know how this point need to be hide. So that's why we use sampling corner, and it will create automatically the last row and or this one, the last row, the last column, but use the value in this voxel is high value in the last vertices. And I think I hope you know what that means. So that's why we need a corner here. You can see corner. It will create one more, and this information later will be in last voxel, last point where it's used. So that's super important thing. Keep in mind. Use sampling corner. Okay, it's our base terrain. Now yeah, put here times and here, 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 and here. Or we can maybe use the second attribute, total size. So we don't need to time it by x size and y size, and we can use directly this one, and here as well. We don't need to multiply it also. So now it's our final terrain, 18 million voxels. But because it's just empty flat terrain, uh, it is super light. It's just 2.3 megabytes because it's internally compressed. Because everywhere is like value zero height. So we can create the massive terrain here, like 100 kilometer, 100 kilometers. It still will be super light. So, and we will not use this super big terrain for any computation because it will crash our computer, and that's why uh, we will have this series about simulation, these massive worlds. So here we will use another wrangle, triangle, and we will write some values directly to this high field. because later on it will be split to parts, and this terrain can use some attribute we already made for inner computation, and we don't need to promote to work item and later on uh, copy to parameters, and that then uh, can use ourselves that information. It's count attribute means second input from Wrangle. It will be or it's count index. Okay, y count 0 and size the attribute one and size set the attribute zero keep count count set. Oh, I count I count size and size. Okay, and now our brain will have this information. Okay, what else we need to make the student prepare? Um, Basically, it's all we need. It seems it's all we need. And prepare. So we'll put in the terrain attribute. Oh, first we need to save it. So save node type, and inside our terrain pipeline input HDA processor. Input node HDA terrain prepare. Yes. Uh, Something, yes. At HD parameters automatically, so it's automatically created here, and generate automatic cook type auto process patch create file. outputs. No, we don't have any outputs. And asset outputs, yes. Right, outputs. And here we will use dollar $OS OS your SC so it's here the line 3 right here train prepare and here from geo package. Okay, so we can now start the copy. Let's sync and then we have our first work item. Work item here we have our train simulation geo train prepare geo SC. For performance reason, we can use maybe not out of process, but use the services. This cook time, what it means. If you can check the help from SideFx, we can service this name uh, or cook type there. Cook type, cook type. It's in process. This program determines whether or not work items should clean up instances of the HDA that they create while cooking. If this parameter is enabled, each work item will create and destroy an instances of the HDA it cooks, and this parameter is enabled in process. If the parameter is disabled, so like out of the process, each date instances will not be deleted after cooking and reuse that instance. So it will take some if like if we have very light HDA, like it takes like 15 milliseconds to process. The time for creating instance, copy HDA, copy parameters, then process this. The time for preparing the instance of Houdini and shutting it down is considerably large. So in this mode, we will use like out of the process or services, because services uh, are automatically created for us, and you can click on this button. It's not like button. This is like button with changing, but here tasks it's already button. You can click PDG services and you can see these three are automatically created for us in Houdini 20. In Houdini 19.5, you can maybe create a new one, but for us, I will create also. It's Houdini service, so it's Houdini application. Session name will be HDA, and we can check to automatically start services. So when we will start cook, it will look at each processor that it needs to run with the services HDN, and it's not already started. It will start your 5 instances. We can start it also manually here. It will take some time, but we later uh, we will save because it's not to be started again. And now 5 instances are running, and we can check in also if the manager, and we have our normal application Houdini, and here is our 5 instances of Python, and Houdini or this scheduler will use these instances for computation. So it will not use our Houdini main application. It will use these 5 process already started. So it will be super quick, super quick. So we can now delete and run it again. So that they cook this node. Ah, no, it's really immediately.